Good afternoon, everybody. Thank you for coming to the PhD Forum, and thank you all for staying all the way to listen to my presentation today. Today, I'm going to be talking about the impact of automated vehicles and pooling on urban transportation. This is a joint work of myself and Professors David Keith and Charles Fine from System Dynamics and Operations Management Groups. Current automobile transportation is not sustainable and not efficient. Cars are the largest source of greenhouse gas emissions from the US transportation sector, and an average driver loses about 2.5 weeks per year due to traffic. And if you're in Boston, this is about a month lost due to congestion. So these pictures are from China and India, but they're well too known for many of us from personal experience around here in the US, especially if you have lived in Boston. So fortunately, automated vehicles are coming to the market. Combined with ride-sharing or pooling, they offer the potential to substantially improve our transportation options and make them cheaper and more convenient. And if we all drive electric, we will also be able to eliminate tailpipe pollution in the cities. So while many believe that these technologies or revolutions will revolutionize and substantially improve urban transportation, others are more skeptical. So our goal in this work is to understand what is the impact of automated vehicles and ride-sharing or pooling on urban transportation operations. So automated vehicles offer a fantastic technological solution to reduce most of the negative externalities of driving as we know them today. So by offering safer, faster, and more convenient driving, they will reduce traffic and pollution. And at the full level of autonomy, people will be able to work, play, or sleep during their commute, all without the stress of driving, use their time more productively. So however, if the driving were to become so effortless and convenient as AV technologies promise us, so then this might induce additional driving, or from the current population of drivers taking additional discretionary trips, and also from the underserved population segments who cannot drive today, as well as new business opportunities, where all these mobile pods will be used for something conventional such as pizza and goods delivery, and to something less conventional such as shoe boutiques, mobile offices, and even mobile hotels. So people will drive more, and more people will drive, offsetting or even potentially overtaking the AV-induced benefits of the AV technology. So such that we as a society might end up in a situation where we are increasingly dependent on vehicles and have more congestion and higher pollution than we have today. So recognizing this problem, researchers suggested that pooling is the solution to reduce congestion. So they argue that if we have more than one person in a car in most of the trips, then this will effectively allow us to serve the same number of passenger miles with fewer vehicle miles. And of course, if we have fewer vehicles, then effectively it means less congestion. And at the same time, pool trips are going to be cheaper because costs are going to be split among passengers. So it seems like a win-win situation, but is it? So not necessarily, because these suggestions do not consider the urban transportation as a system. And in this system, if pooling will make driving cheaper, it will increase attractiveness of this transportation mode such that it will start drawing people away from other transportation modes, and specifically public transit, which in the US has been experiencing a precipitous decline in ridership for many years, especially in the wake of the introduction of ride-hailing services. For example, Boston reports that MBTA loses 35 cents for every ride-hailing trip. And in the US, subway ridership has been falling since 2015, while ride-hailing services have experienced a substantial increase in ridership over the same period of time. And this is not just New York or Boston, ladies and gentlemen. This is all the other metropolitan areas, major areas in the US report similar trends. So in the urban transportation system, the well-intentioned move to promote and incentivize automated vehicles and pooling to reduce congestion and make mobility affordable and available to more people might actually have the unintended consequence of triggering the public transit downward spiral, where we might have both worse public transit quality and more rather than less congestion on roads. To the best of our knowledge, there aren't any studies today that look at the impact of automated vehicles and pooling on urban transportation as a system. So our goal here is to understand the root cause of the problem and propose policies to make more sustainable, affordable, and better transportation of the future. So let's look at the dynamics of the urban transportation mode choice in the system where commuters have two options, public transit and driving. So on roads, driving time combined with the operating cost per riders determines the utility of driving. which is then compared to the utility of an alternative option, in our case public transit, determines how many people choose to drive, and based on the average occupancy of vehicles, determines the number of cars on road, therefore congestion, travel speed, and driving time. So this system, given the road capacity, is in equilibrium, such that every marginal trip is unattractive for commuters, either because it's too expensive or it would take too long. And this is a balancing feedback, such that given any exogenous shock, the system will converge to an equilibrium. For example, if the new roads are built, then the congestion will go down, the driving time decrease, and the utility increase, inviting more people to drive and putting more cars on road and increasing driving time again. And in fact, this phenomenon has been frequently observed in the cities around the US and the world today, where The Economist documented that after the new roads or bridges in the cities are built, congestion returned and gotten worse in as little as 3 years. So on the other hand, the utility of public transit for commuters is determined by the network of routes and frequency and reliability of service. We represent these attributes collectively as public transit quality. So the higher is the utility of public transit, the more people choose to take public transit as their commuting options, generating more revenue and leading to more investment in sustaining public transit quality. This is a reinforcing feedback. And also, government can contribute to public transit maintenance if the revenue ridership are not enough. However, this contribution is likely to be lower because of the unwillingness of many governments to subsidize financially unsustainable public transportation systems. And also, public transit quality erodes over time due to the wearing out of equipment. So therefore, the relation between the maintenance inflow and the erosion outflow is critical in determining the state of the system. Because if the inflow falls below the outflow, then the feedback R1 will become vicious rather than virtuous, such that the lower public transit quality will lead to lower ridership and even lower public transit quality. So dynamics of these subsystems in isolation are easily understood. However, the potential for significant unintended consequences emerges if we consider endogenous interaction. And in this system, the key dynamics to pay attention to are the following. So if there are fewer vehicles on roads, driving will get more attractive because the roads are less congested, and this is a balancing feedback. However, if there are fewer riders on public transit, then the public transit will get less attractive because the quality will erode. And therefore, it's a reinforcing feedback. So therefore, it's a fundamentally different property of these two subsystems we have to pay attention to. So now, let's use this model and analyze the behavior of the system quantitatively. So this is the system as we have it today without the introduction of automated vehicles and pooling. And this is the vector plot that depicts the state space of the system, where x and y axis represent state variables. We have driving time and public transit quality. And the arrows indicate direction of change in these state variables from anywhere on the map. So the system we have today is characterized by two stable equilibria, green dots, and one unstable equilibrium, red dot. For small perturbation around the green dots, the system will converge back to the same equilibrium, such that, for example, if the quality of public transit drops a little because of the temporary disruption in service, for example, due to track works, then over time it will return back to the same equilibrium. However, if the disruption in public transit quality is high enough and the tipping point is crossed, which is indicated here by the red dashed line, then the system will converge to the lower equilibrium with very highly congested roads and low quality of public transit. And massive investments are needed at this point to bring the system over the tipping point and bring it to the upper equilibrium. So let's see what happens if in this system we introduce automated vehicles and pooling. So we will see that the state space now changed completely. And from anywhere on the map, the system is converging to the single equilibrium point in the lower right corner with highly congested roads and virtually non-existent public transit. So why it happens? So in this system, automated vehicles and pooling made driving so much more attractive that people started shifting away from public transit, and eventually public transit collapsed. So why the roads are highly congested, the public transit is not even an option. So therefore, in this situation, we clearly have less than optimal results because the negative externalities of driving have just been amplified. So let's see what we can do with that, because the root cause of the problem is the increased attractiveness of driving. So therefore, we can try to make driving less attractive by introducing road pricing. We introduce road pricing imposed on all vehicles to internalize some of the negative externalities they have on congestion and air pollution. And we also reinvest a fraction of this tax in maintenance of public transit quality. So now we'll see that we have a much better system, where equilibrium is in the upper left corner, and from anywhere on the map, we converge to the roads that are not congested and the public transit that has high quality. So what changed? What happens in this system? So in this system, the more people drive, the more tax revenue they generate, and the more money can be spent on increasing public transit quality. And while in this scenario, driving is more expensive, ultimately, this outcome is more advantageous, not just for commuters who use public transit, but also for drivers. Because those who choose to drive, they enjoy free roads and faster commute time, and those who decide to pick public transit, they enjoy high quality and the reliability of the service. So to conclude, so we know that automated vehicles, they provide fantastic potential to reduce or even eliminate most of the negative externalities of driving as we know them today. However, we know that combined automated vehicles and pooling will make driving or automobile transportation in general so much more attractive relative to the other transportation modes, so that people will start shifting away from them. And therefore, there's a potential for substantial unintended consequences where the public transit might collapse. And if this happens, then we might have higher level of congestion and more air pollution than we have today. So this research contributes to the broader literature of urban management and operations. And then we show that effective policies need to internalize some of the negative impacts of automated vehicles and pooling on congestion and pollution, not make driving more attractive. And also for managers of ride-hailing companies, we emphasize the fact that in order to realize business opportunities associated with these new technologies, automated vehicles and pooling, so the substantial emphasis should be made on sustaining public transit and then maintaining high quality of public transit such that road transportation remains attractive. Benefits of automated vehicles and pooling are real, but we have to manage driving demand to make sure that we have a commuting that is good for everybody. Thank you.